and in time want to establish a fund for their grandson's education, what lump sum must they deposit at a 12.8% annual interest rate compounded annually in order to have $50,000 in the fund at the end of 15 years? So we're given the amount that they want to have in the fund. So we use that as the amount, which is the future value using the compound interest as $50,000. The annual rate, which is 12.8%, we convert that to a decimal, and that equals to 0.128. We use that by dividing the number of compounding periods per year. And compounded annually, of course, is just a 1-year compounding period. So we write the fraction R over M using 0.128 over 1, which is the same as 0.128. So now we move to the number of compounding periods. So we're told by the end of 15 years. So the number of compounding periods, that's our N, it's equal to 15. And we multiply that times 1, because of course we only have the 1 year. So our N is equal to 15. So using our formula, as you can see at the bottom, the compound interest formula, we fill in everything that's given to us. So we have our amount, which is $50,000, equals to the principal, which is unknown, times 1 plus 0.128, and we raise that to the 15th power. So now let's talk about how we can solve for our principal. So taking the 1 plus 0.128 and raising that to the 15th power, we get a very long decimal, and we leave that, of course, in the same equation formula such that we can divide the decimal that we received by adding and raising that amount to the 15th power. We divide that decimal on both sides so that we can isolate the P for principal. Once we divide away that decimal on the right, we end up with the isolation of our principal amount, P equals, and after dividing, we end up with $8,209.82.